Bismillahirrahmanirrahim. Assalamu alaikum dear students. I hope you all are fine and in the best conditions of your health. So in continuation with the lecture on the aromatic hydrocarbons, so we'll study the introduction to aromatic hydrocarbons, and this is the second part of this lecture for the course of fundamentals of organic chemistry. So the key concepts which we shall discuss in this lecture are aromatic. What do we mean by aromatic compounds? What do we mean by anti-aromatic compounds? What are non-aromatic compounds? Also, we shall study about what is the Huckel rule and what are the annulenes. So, firstly, we know that benzene is associated with some extraordinary stability, and this extraordinary stability of the benzene is because of the delocalized electrons of the pi system. Right, because of this delocalization, so benzene does not undergo addition reactions, and this extraordinary stability of the benzene is known as aromaticity. Right, so benzene and polycyclic benzenoids all are aromatic, means they are extraordinarily stable because of their delocalization. So what are polycyclic benzenoid? Polycyclic benzenoid means those compounds that have more than one benzene as a part of their structure, or the compounds which resemble benzene, just like pyridine. Right, so benzenoids means compounds which resemble benzene. So benzene and polycyclic benzenoids, all of these have extraordinary stability because of the delocalization of pi electrons. But this extraordinary stability is not only associated with benzene or benzenoids. So all compounds can be checked for aromaticity. Right, but for a compound to be aromatic, it is essential, number one, that this compound must be conjugated, it must be cyclic, it must be planar. Right, so any polyene which is cyclic, which is conjugated, which is planar, can be aromatic, but the deciding factor whether it will be aromatic or not is that it must have 4n+2 number of pi electrons. Right, so if a system is cyclic, it's conjugated, it's planar, but it does not have 4n+2 number of pi electrons, it cannot be aromatic. Right, so deciding factor is that it must have 4n+2 number of pi electrons. So what does that means, 4n+2 number of pi electrons? So you can change the value of n, so you can put n to any value. It can be 0, it can be 1, 2, 3, so on. So just change the value of n and see what number you get. So if the number you get from this formula is same as the number of pi electron in your system, then your system will be aromatic. For example, if I say that I have a system that has 8 number of pi electrons, right, and I want to check whether it is aromatic or not, so I will check whether I can get 8 number from this formula or not. So if I put n is equal to 1, then the answer will be 6. If I put n is equal to 2, the answer is 10. Right, so I cannot get 8 number from this formula. It means that if a system has 8 number of pi electrons, it cannot be aromatic. Right, similarly, if a compound has 6 number of pi electrons, I will check whether it's aromatic or not. So I will check whether 6 is an answer from this formula or not. So if I put n is equal to 1, then I get 6 as answer. So 6 is an answer in this formula, and 6 is also the number of electrons, pi electrons in my system. Therefore, the compound which I am considering will be aromatic. Right, so depending on if your system has this 4n+2 number of pi electrons or not, it can be aromatic or it cannot be aromatic. In contrast, there are some systems which have 4n number of pi electrons. Right, so systems which have 4n number of pi electrons, the increasing conjugation destabilizes such system. Right, so conjugation increases stability of aromatic system, but there are some compounds in which the conjugation decreases the stability of a system. Right, so in such a system in which conjugation decreases the stability of the system, such compounds are known as anti-aromatic. right? And the criterion for such system to be anti-aromatic is that system must be cyclic, should be conjugated, should be a polyene, should be planar, and should have 4n number of pi electrons, right? So only difference between the aromatic and anti-aromatic is number of pi electrons. In case of an aromatic system, it must have 4n plus 2 number of pi electrons, but in case of an anti-aromatic system, it must have 4n number of pi electrons, right? So this pattern of having 4n plus 2 system and being aromatic, and a system that's having 4n number of pi electrons and being anti-aromatic, this is known as Huckel rule, right? Also always remember that if a system is non-planar, its p orbitals cannot sufficiently overlap to form delocalized system. So if a system is not planar, then it will be non-aromatic and it will have alkene-like properties, right? So whenever a system is non-planar, it cannot have delocalization, and since it cannot have delocalization, it will not be stable, and such systems will have typical properties of alkenes, right? So this is the difference between aromatic, anti-aromatic, and non-aromatic system. So firstly, we'll consider anti-aromatic compounds. Just for this purpose, we will take the example of 1,3-cyclobutadiene, right? So this is cyclobutadiene system. It's planar, it's cyclic, it's conjugated, right? And it has 4n number of pi electrons, right? Why 4n? Because it has 4 electrons. 2 electrons in this pi bond, 2 electrons in this pi bond. So it has 4 number of pi electrons. So if n is equal to 1, this is a 4n system, right? So this compound, if you check its properties, it is very air sensitive, highly reactive as compared to its analogues of butadiene and cyclobutene, right? This molecule is not stable. Instead, it is highly unstable system because of ring strain, right? So that's why it is anti-aromatic, right? So see the criterion. So according to the criterion for anti-aromaticity, it is important that system must be cyclic. So it's a cyclic system, should be planar, so it's a flat system, should be conjugated, you can see the conjugation, and should have 4n number of electrons. So all of these criterions are being fulfilled in this structure, right? As a consequence, the structure is rectangular and the two dienes from the isomers, and this is a sort of transition state rather than the isomeric forms, right? So these are in equilibrium with each other, these are not in resonance with each other, right? Because of systems instability due to ring strain. So here we have another example. Now we will consider the example of non-aromatic compounds. So here we have 1,3,5,7 Cyclooctatetraene, right? So we have an 8-membered cyclic ring and it has 4 number of pi electrons. So you can see that it has 8 pi electrons, 4 double bonds. So 8 is a 4n system. So if you put n is equal to 2, then it will be a 4n system with 8 electrons, right? So apparently it should be anti-aromatic because it's 4n system, but we'll see whether it is anti-aromatic or not. So it's an 8-membered cyclic ring, and this system is not planar, right? So it's compulsory condition for a system to be anti-aromatic or aromatic that the system must be planar. So this molecule is not a planar molecule. So since this molecule is not planar, so the p orbitals will not be able to overlap and form a delocalized system. So this is not an anti-aromatic system, right? Since it's not stable, it's not a planar system. So this molecule is a yellow liquid. It is stable if you place it under cold conditions, but when heated it readily polymerizes. So this molecule is readily oxidized in air. It can be catalytically hydrogenated to form the cyclooctane, and it can undergo electrophilic addition and cycloaddition reactions. So it has all the reactions of an alkene, right? It just behaved as if it is simple polyene, right? So it has a top shift geometry, means it's not planar, and the double bonds are nearly perpendicular to each other, so they are not part of conjugated system, right? So since the basic condition of planarity is disturbed here, so although it's a 4n system, but since this molecule is not planar, therefore this molecule will be non-aromatic, right? So here we have another system. So here we have the category of cyclic conjugated polyenes, which have 4n plus 2 pi electrons, right? So unlike the cyclobutadiene, which was anti-aromatic, and cyclooctatetraene, which is non-aromatic, certain higher cyclic conjugated polyenes are aromatic, right? The criterion for aromaticity will be the system must be cyclic and conjugated, they must have 4n plus 2 pi electrons, and must be planar to show the delocalization, right? So these are the criterions. If either of these criterion, any of these criterion is not fulfilled, the system will not be aromatic, right? So we saw that butadiene, always was cyclic, it was conjugated, it was planar, but it was 4n system, so that was it was anti-aromatic, and it was highly unstable because of the ring strain. Cyclooctatetraene was not a planar system, so that why it was non-aromatic. Now we have systems which are fulfilling the conditions, so they are cyclic conjugated system, they are containing 4n plus 2 number of pi electrons, and they are planar to allow the delocalization. So let's consider an example. So here we have an example of 1, 3, 5, 7, 9, 11, 13, 15, 17 cyclooctatetraene. So this system is containing 18 pi electrons, right? So if you have this formula for n plus 2, just put n is equal to different numbers. So if I put n is equal to 4, 16 plus 2, 18. So 18 comes out from this formula, right? So we have a system that has 18 pi electrons, and the formula also gives 18 electrons. So that's why the system should be aromatic. So let's see all of the criterions one by one. So this is a cyclic system, right? It's a conjugated system. You can see its conjugation is throughout the system. It's a planar molecule. It's just a flat molecule, and it's also following the Huckel rule. That is, it has 4n plus 2 number of pi electrons, right? So with all of these criterion, this system is aromatic, and it will show resonance, right? So we are not using the equilibrium arrow, we are showing the resonance arrow here, right? So you can just see the placement of double bond. So here there is a single bond, and in this structure the double bond has shifted here, right? So this is the phenomenon of resonance which is observed here, right? So both of these are resonance forms, and both are very stable, and both of these are aromatic. So in the previous structure which we have seen, it was using a very lengthy name for that polyene. So it's very difficult sometimes to write such lengthy names and to understand what these names means. So a scientist named Sundimer, he introduced a simple naming system for the naming cyclic conjugated polyene. So according to this system, a system, if it's conjugated and if it's monocyclic, it can be mentioned as an annulene, right? So n is any number which is indicating the ring size, that is indicating the number of carbon atoms in a ring, right? So if a system is conjugated and if its system is monocyclic, then we can mention it in the form of annulene. For example, if a system has 4 carbons and it is a conjugated system and it is in the form of one ring, right? If monocyclic ring, then such system will be called 4-annulene. So benzene having 6 carbons is a conjugated system and is a monocyclic system, so benzene can be considered as a 6-annulene. Similarly, cyclooctatetraene can be considered as 8-annulene, and the structure with very lengthy name in the previous slide can be considered as 18-annulene system. So keep just one thing in mind, that it's not compulsory that annulene should be aromatic, right? So any annulene can be aromatic, it can be non-aromatic, it can be anti-aromatic, right? So it doesn't mean whenever you are mentioning the use of annulene that it should be aromatic, right? So if a system is consisting, if a molecule is consisting of only one ring, and if it is conjugated, then you can use the word of annulene for such system. So even a system can be non-aromatic and still be aniline, right? However, if a system has double bonds which are not conjugated, then you cannot use the word of aniline for such system. So benzene is aniline, cyclooctatetraene is aniline, but butane is not aniline, right? Similarly, butene is not aniline. So it's compulsory for a system to be aniline is that it should be conjugated and it should be monocyclic. So only these criterions are applicable for aniline. So it doesn't matter if the molecule you're considering is aromatic, anti-aromatic, and non-aromatic, right? So let's do some summary for so far what we have considered. So we can summarize here that any aniline, so what do you mean by aniline? Aniline is any cyclic system, a monocyclic system which is conjugated, right? So in case if you have any aniline which is planar, which is cyclic, conjugated, and has Huckel number of pi electrons. So what's Huckel number of pi electrons? Means it has 4n plus 2 number of pi electrons. Then such a system will be aromatic and will be associated with increased stability, right? Then if you have any aniline with 4n electrons, such as cyclobutadiene and 16 annuline, right? Then such systems are considered anti-aromatic. The remaining conditions are also same. So for a compound to be anti-aromatic, it is compulsory that it should be planar, it should be cyclic, it should be conjugated. The only difference between aromatic and anti-aromatic is the number of pi electrons. In case of aromatic compounds, the number of pi electrons should be 4n plus 2, but in case of anti-aromatic, the number of pi electrons should be 4n, right? Then we have third category, annulenes, in which the cyclic delocalization cannot occur because of angle strain or static strain or whatever be the reason. So in case if a system is not delocalized, although it's conjugated but it's not delocalized, or if a system is not planar, then in such case such annulenes are known as non-aromatic, right? So this is the major difference between aromatic, anti-aromatic, and non-aromatic. So aromatic and anti-aromatic are almost same, except they differ in the number of pi electrons, right? So aromatic compounds are highly stable, whereas anti-aromatic compounds are highly unstable. So normally these anti-aromatic compounds have some angle strain associated with them. In case of annulenes, so they are cyclic, they are conjugated, but the problem is that they are not planar, right? So since they are not planar, they cannot have delocalization, therefore they are considered as non-aromatic. Now we have conditions. If we have a cyclic polyene that is not conjugated, right? If a cyclic polyene is not conjugated, then it will not be an annuline and it cannot be in non-aromatic as well, right? So this condition of aromatic, anti-aromatic, and non-aromatic, these conditions are applicable only for a system if they are conjugated, right? So you must know about these terms. So here we have different annulenes and polycyclic and cyclic polyenes, and let's see if we can see if they are aromatic or they are anti-aromatic. So firstly we have this cyclobutadiene. You can see here we have two double bonds, so it means it has 4 pi electron system. So you know 4n is an anti-aromatic number, right? So it should be anti-aromatic. So you can see if it's planar, so it's cyclic, it's conjugated, it's planar, and it has 4n system, so it must be anti-aromatic. Now we have this benzene ring. So benzene ring is planar, cyclic, it's conjugated, and it has 3 double bonds, meaning it has 6 pi electrons. So 6 is a 4n plus 2 system. Okay, now we have this Cyclooctatetraene system. So you can see it is 4n system because n is equal to 2, so it has 4 double bonds, so it must have 8 pi electrons. With 8 pi electrons, it's a 4n system. However, since it is not planar, so that's why it cannot be anti-aromatic, so it will be aromatic system. Now we have 10 annulenes, so you can check if it's a 4n plus 2 or 4n system. So if you put the value of n is equal to 2 in 4n plus 2 system, then 10 comes out number. So although 10 is indicating it's that it's a aromatic compound, but since the molecule is not planar, so it cannot be aromatic, right? So it's a very interesting condition that although it has 4n plus 2 number of pi electrons, but it is not aromatic because it's non-planar, right? So it's very important that a system must be cyclic, it should be conjugated, it should be planar, and should have 4n plus 2 number of pi electrons to be aromatic. So this example is a non-aromatic system. Now we have 14 annulenes. So here we have 14 annulenes because it has 14 number of carbons in the system. So it is a planar system, it is conjugated, it is cyclic, and 14 is a 4n plus 2 number, right? So if you put n is equal to 3 in 4n plus 2, so you can get 14 number. So 14 is an annuline, 14 is an aromatic number, so it's also planar, cyclic, and conjugated, so this 14 annuline will be aromatic. Next we have 16 annulenes. So 16 is a 4n system. So if you put n is equal to 4, so in 4 into 4 is 16. So 16 is an 4n system. It's almost planar, cyclic, it's conjugated in a 4n system, so it should be anti-aromatic. So since it's anti-aromatic, it means it must have the destabilizing factor, so it should not be stable thing. Then we have 18 annuline system. So you can see it has 18 number of carbons inside the ring. All system is conjugated, it's cyclic. So this 18 is a 4n plus 2 system. So if you put n is equal to 4, right? So 4 into 4, 16 plus 2, 18. So 18 is a 4n plus 2 system. So this system is also planar, it's cyclic, and it's conjugated. So all of the criterions for aromaticity is met. So 18 annuline is also an aromatic system. Then we have this cyclobutadiene. So this cyclobutadiene is not aromatic because this carbon is not conjugated, right? So this is sp3 carbon, so it's not a conjugated carbon. Therefore the cyclobutadiene is non-aromatic because it's not a conjugated system, right? It's not fully conjugated system, therefore it will be non-aromatic. Here we have 12 annuline. So 12 annuline is nearly planar system, and you know 12 is a 4n system, so if n is equal to 3, the answer will be 12 for 4n system, right? So 4n is a 12 annuline is a 4n system, so it's planar, it's cyclic, and it's conjugated, so system will be anti-aromatic, so it will not be a stable system. Now we have 1,4-cyclohexadiene, right? So this system has 2 pi electrons, 2 double bonds mean 4 pi electrons, but system is not conjugated. So since system is not conjugated, so that will be non-aromatic system, right? So that will not be aromatic. So it will not be aromatic, it will not be anti-aromatic, it will be a non-aromatic system, right? So it's not compulsory that if a system is a 4n system, it should be anti-aromatic. So you have to check other factors as well. So system must be planar, system must be cyclic, system must be conjugated, and system must have 4n or 4n plus 2 number of pi electrons to be aromatic or non-aromatic. For example, if we have a system, it is cyclic, it is conjugated, and it has 4n plus 2 number of pi electrons, but the system is not planar. So on the basis of planarity, it will not be aromatic, although all other criterions for aromaticity is met. Similarly, a system may be a 4n system, but it will not be conjugated. So if it's not conjugated, then it cannot be anti-aromatic. So for a system to be aromatic or anti-aromatic, so it's compulsory that this system must have the system must be cyclic, must be conjugated, must have 4n plus 2 system or 4n system if it's anti-aromatic, and should be planar. So if any of the conditions, if any of the criteria is not met, then the system will not be aromatic or anti-aromatic. So just keep in mind that aromaticity is not smell. So aromaticity is the stability which is associated with the delocalized electrons. And also keep in mind that the delocalization is effective only if the system is planar, because the delocalization is caused when the pi electrons can overlap with one another, right? But if the system is not planar, then the p orbitals are not overlap. They are not able to overlap with each other. So because of the poor overlap, so the delocalization cannot be made effective, right? So whether you have aromatic system or you have anti-aromatic system, so both of these should be planar, should be cyclic, should be conjugated, right? The only difference between aromatic and anti-aromatic is the type of system. So in case of aromatic system, this is 4n plus 2, and in case of anti-aromatic system, this is 4n system. So aromaticity is associated with extraordinary stability, whereas anti-aromaticity is associated with extraordinary instability. So most of the times the 4n systems or the anti-aromatic systems are unstable because of steric strain or the steric hindrance, right? So they are unstable. In case of non-aromatic compounds, the non-aromatic compounds will show the reactions of typical double bond, right? So they will not show any reactions just like the aromatic reactions, right? So aromaticity is an important thing in stability. So aromatic compounds do not undergo addition reactions, because if they undergo addition reactions, then they will end up their pi electrons, and if they end up their pi electrons, if they lose their pi electrons, they will lose their delocalization and stability, right? So this is important for the aromatic compounds to retain their stability. Now the Huckel rule or the 4n plus 2 system can also be applied to charged molecule as well, right? It's not important, it's not compulsory that for a compound to be aromatic it should be neutral. So sometimes the compound can be charged and can still be aromatic, right? So for example, let's take the example of cyclobutadiene system. This is cyclobutadiene, right? And this system is not conjugated, right? Because we have an sp3 carbon here. But if we can remove this hydrogen from here, because this hydrogen can be easily removed, you can see the pK value, right? So pK value is higher, then acid strength is higher, right? If pK value is lower, then you can predict about the acid strength, right? So this pK value, sorry, that's inversely related to the acid strength, right? So this hydrogen, if we can remove this hydrogen to some extent, somehow, so after losing this hydrogen, so we'll get a negative charge here. So we are having 2 pi electrons, 2 pi bonds here, so it means it has 4 pi electrons, and by removing one more proton, so we'll get a negative charge. So these 4 pi electrons plus this negative charge, they together form 6 pi electrons. So 6 is a Huckel number, right? So this cyclobutadiene, although in neutral state it's not aromatic, it's a non-aromatic system, but when it loses a proton, it will form 6 pi electrons. So because of presence of 6 pi electrons, then since system is conjugated, system is planar, then the system will be, since system is planar, system is cyclic, system is conjugated, and system is also following the 4n plus 2 rule. Therefore, this cyclobutadienyl anion will be aromatic, right? So this is all the criterion for aromaticity. So we have considered in this lecture about aromaticity, anti-aromaticity. We have also studied about what is the non-aromatic compounds. Also we have seen that it's not compulsory for an organic compound to be neutral in order to be aromatic. So certain anions and certain cations can be aromatic as well. So I hope that you have understood this lecture well. In case if you have any question, please feel free to ask. Thanks for your attention.